session, please go ahead to drop a message on the Discord server so that we have the others join in and we have more people join the session. Just drop a message on your channel, then everyone can come on this call. So on this call, we have Ebenezer. Ebenezer is a cloud slash DevOps engineer based in Ghana. So thank you, Ebenezer, for coming on this call today. Thank you for giving back to the community.
Sure, sure. Thanks for the opportunity too.
All right. I think today our class is on introduction to tech. So Ebenezer, the class is all yours.
Right. So thank you very much, Amaka, and thanks for the opportunity to be here. It's a great honor. I mean, looking at the work that you're doing, it's a very nice. I feel like it's a very nice opportunity that you've given to me. And as Amaka said, today we'll be looking at introduction to cloud computing. Right. So I think I'll go ahead and share my screen. Um, Just I would like this session to be as interactive as possible because this is an introductory course where we're not going to learn any technicalities, right? We're just going to be introduced to the course. So if you have any queries, any questions, please or kindly feel free to, share in the chat any queries that you have. Right. So let me go ahead and share my screen. But I trust I'm audible. Can everyone hear me? You can just, give me a thumbs up or a yes in the chat.
Okay. Yes, we can hear you.
Great. So let me share my screen in a second. Right. Can you see my slides, my presentation? Is it visible?
Okay, so yes, we can.
Great, 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 great. Right. So at any point in time, also, if you can't hear or see my screen, just kindly prompt me, and I'll just fix it. Now, as I mentioned, today I have a very simple task. I don't know how simple it is, but today we'll be looking at introduction to cloud computing. Right, and this is my first time here, so I would like to introduce myself officially. I'm Ebenezer Bompong, a cloud engineer at Scale Capacity, and I have a couple of certifications. I'm certified in both AWS and Microsoft Azure. I'm also a community builder, and then currently, unfortunately, or fortunately, I'm only very active on LinkedIn. So if you have any questions after this session and you would like to reach out to me, you can just shoot me up a message on LinkedIn and I'll do well to respond to you. Right. So yeah, let's move ahead. Um I I This is a very small or short disclaimer. I use a couple of images in this presentation. Right. So I do not own any image used in this presentation. So except for this picture, this is mine, but then any other image, I don't own it. So it was just included in this for just to give us a better idea of what some of the concepts are. So yeah, just a little disclaimer, right? So let's look at the outline for today. So as I mentioned earlier, today we'll be looking at the introduction to cloud computing. So we'll start with the evolution of cloud computing, how cloud computing came to being, what it is, and also some characteristics of cloud computing, right? And we'll be looking at some concepts in cloud called the cloud service models, the deployment models, and we'll look at some benefits of the cloud, right? And also a very important, topic that I want us to look at is the shared responsibility model in cloud computing. Right. So at this point, is everyone okay? Can we move ahead? And is everyone sorted? Um, any question at this point? All right. I can't see any questions on my popping up on my screen. So if not, I would like us to, just start right away. Right. So how cloud computing began, and I would like to, just take us back to a bit of history. It's not, I'm not going to give you any details. I'm just going to, give us a summary of how what cloud computing is and how it started, right? And I'll be using some analogies for us to really get the whole idea of cloud computing. I know many of us hear cloud computing, and sometimes I feel like the naming doesn't really help because people think it's some invisible something in the air that you can just upload your stuff to, right? But that's not the case. Right. So today we look at how it came into being and how it is now, right? So as I mentioned too, I'll be using some analogies along the way so that we just get a clear, understanding of everything. Now, I don't know how many of us did ICT in school, but then in the early ages when tech was starting, we had different types of computers. We had mini computers, microcomputers, mainframe supercomputers, and all that stuff, right? So what large organizations or even mid-sized organizations used to do is that they get mainframe computers, right? Now, mainframe computers were really powerful, like their processing power was just top notch and they're very powerful. But then because they're very powerful too, that means that they were really expensive. Right. So let's say this organization goes to buy a mainframe computer, and then even though it's really, really powerful, that can use it for a lot of things, it was being used for one thing at a particular time. Right. So let's say you buy your computer or laptop, and then in your organization, and you can only use it for Microsoft Word at a particular point in time. Now, mind you, this is a very, very, very expensive computer. And then if someone wants to use it for maybe Google, because you're using Microsoft Word, the person would have to wait or something, right? Because it was being used once at a time, right? So the concept of resource pooling now, just don't take the name. I'll explain, but don't let the name confuse you, right? So the concept of resource pooling came up because they needed to maximize the capabilities of the mainframe computers. Right. As I said, they're really, really powerful computers. Their processing power is very, very high. Now, resource pooling gave them the chance to, let more than one person use that computer at a particular point in time. Right. So now if you are using a computer, I can also get access to the computer and also use that particular computer, meaning we are sharing the resources, we are sharing the backbone of that uh, mainframe computer, thereby what maximizing the capacity, using it optimally. Right. So now I can get access to it, you can also get access to it, someone too can get access to it in the same organization, using it for different purposes, right? Let me try and use this analogy for us to get it really well. So, okay, let me use a diagram. Right. Um, in I don't know where you are joining from, but in my part of the world, lands are really expensive, right? So you're going to buy a piece of land is it's quite pricey, it's quite expensive. So let's take for instance, you go and buy a piece of land, right, and then you build a building on it, right? But that building, only one person can get access to it at a particular point in time. Mind you, that building, that land is really, really expensive. So just imagine if you have a whole family of 10 and only one person can be in that building at a particular point in time, right? It's not being used optimally, right? Now, what resource pooling came and did was that now it converted that particular house into an auditorium where now all of us can get access to that building. So now, even though you're in, I can also be in, your brother can be in, your sister can be in, right? And we are all using that particular building, right? So that's the whole concept of resource pooling. We are sharing the resources of that particular machine or that particular computer, right? So now that was what was going on in the organizations in the early ages. Now along the way, along the years too, as technology was advancing, a concept called virtual machines came up. Now, a virtual machine is basically an OS that gives the illusion that everybody using that computer or that personal computer, it gives the illusion that I'm the only one using it, right? So you can be connected to that computer. Someone can also be connected to that computer, but then right? I don't know that you're connected in a way. So you have a set of resources that have been apportioned to you, and you don't even see what someone is doing, right? Let's use the same analogy again. Now, let's say that auditorium, that lab, that piece of land that you build an auditorium on it, right? That everybody can use, right? Now, what virtual machine or virtualization did was that now it's going to divide the auditorium into different apartments, right? So you can be in your apartment, you have your own living room, you have your own bathroom, you have your own kitchen, right? Someone too is in that same big building, but in a different apartment where he has a different bathroom, a different kitchen, a different living room, right? So that's the whole concept of virtualization. Virtualization made it seem like it will give you your own OS, your own dependencies and everything, and you just be using the same machine, but then there's like a portion of the resource that has been allocated to you that you are using on your own without you having to, interfere with someone's business. Right. So that's the whole analogy, that's the whole concept of the virtualization of virtual machines. Right. Now, as the years also advanced, technology kept on improving. Now, the whole idea of internet also came up, right? When now people are like, okay, we don't want to be in the same building as that computer. We want to be outside that particular building or that particular office, right? But I want to also still get access to that computer. So now they want to access that computer through the internet, right? So now I can be in my office, and then we can have the machine in a different building called a data center, where I can sit in my office and get access to that particular computer in that data center through the internet, right? So that also, help improve the whole, optimizing the use of the computers or the use of machines in the organizations. Now, other developments also came up. Now people are doing mighty stuff, people are doing other technologies came up. And then along the way, people are like, okay, now we have computers that can be accessed over the internet. Why don't you commercialize it? Right. So now what some organizations did is that, okay, now they're going to build a whole data center, a whole building, install computers in there, set up computers in there, set up virtualization on it, right? Give access to it through the internet. But then we are not going to use it. We are going to, sell it to people, right? Now, using the same analogy of the building, it's like you now having a building with different apartments, but then you are not going to use it, or you are not using it, but then you are renting it out to people, right? Where people just come in, use it after their tenure is done, right? Or their rent is due. They have to vacate the place, right? So that's what people were doing. They were like, okay, we are going to set up a whole data center, set up machines and everything in it, set up virtual machines, right? But then sell it to other people, other organizations, right? Now, that is the whole concept of cloud computing, right? Where you can get access to compute power or compute machines, right, through the internet, right? That's the whole. That's so. Anytime you hear cloud computing, that's what they're saying. That's what there's a saying that there's no cloud. It's just another person's Linux machine or another person's computer, right? There's no virtualization. I know, I'm sure you're used to, iPhones, iCloud. People think that, oh, iCloud, just upload it and go somewhere. It goes to just like you uploading your files to another computer. That is the whole idea of cloud computing, right? And that's what, I think in it started with AWS. So as we speak currently, AWS, Amazon Web Services, they are the largest cloud. They have the cloud space. They control most of the cloud space right now. And then I think it all started I think they started around 2002, 2003, and then they really got in. They started, they really launched it in around 2006 or 2007, right? And when, the other tech giants saw that, okay, this could be something very lucrative because it's a very lucrative something, right? The other tech giants like Google and Microsoft jumped on board. I think that was around 2008, 2009, right? So Microsoft, they called theirs Azure, and then, Google called theirs the Google, GCP, right? So that's the whole idea of cloud computing. It's just you having access to another person's computer that has much more power that you actually have on your own, right? So at this point, do we get it? Are we okay? Are there any queries, any questions? Um, if possible, can I move on or? Are there any questions around that I can answer before moving on? Are we all okay? If I could get a little feedback. Are we all okay? Let's see. Right. Okay. If there are no questions, I'm going to proceed. Right. So, so that's how cloud computing came about. Now, this I think this is just the book definition where they say it says, let me just read it back to you. It says cloud computing is a technology that allows individuals and organizations to access and use computing resources such as servers, storage, databases, networking, software, and more over the internet. Right. And I want to, chip in something here. uh, the key thing is, accessing it over the internet, right? Now, if it gets deeper into cloud computing, you realize that not all resources or all services in cloud are accessed over the internet. But then the general overview is that it has to be accessed over the internet, right? So you're getting access to all these resources, such as service, storage, right? As I mentioned, you have a Google Drive, iCloud, right? Databases. I don't know whether there are some developers here, but then, MongoDB, they have a cloud offering called Atlas, right? That's a very um, clear example of what a cloud database, where you're accessing a database in the cloud, right? You don't set up a database on your own. You just connect to it over the internet and you're good to go, right? So that's what cloud computing is. Now let's look at some characteristics of cloud computing, like what some peculiar things about cloud computing, right? Now, the first point is on-demand self-service or measured service, right? So what this means is that on-demand, you get it anytime you want it, right? So prior to cloud, there used to be a model where it's like you have to set up everything on your own. So if you're an organization, you're a startup, you're not starting up, right? You would have to, go and buy servers, plan ahead, take months to install your networking components, set up your data centers and everything, right? And that's not on demand because that way that you have to plan for it. But here and here right now, if I'm a startup, I'm like, okay, I need a server. I can just create an AWS account, right, and just set up a server within 10 or 5 minutes, right? It's that simple, right? That's what it sees as an on-demand self-service. So I don't need the intervention of maybe another cloud provider or technician or something, right? Me here right now, if I have the right expertise, I can just go into the into an AWS account or Azure account and just create a server on my own. So it's on demand, right? And the measured service. So the measured service is like, you are charged on what you use. So if I go in today, I go and use a machine that has, a very high processing power for 1 hour. I'm not going to be charged for using a computer for the whole day, but then I'm going to be charged for just using that computer for 1 hour, right? So that's one peculiar thing about cloud computing. Then broad access network or broad network access, sorry. So this it means you can access it from anywhere. I mean, if it can be accessed on the internet, that means now it's you have more devices, your phone, your laptop, wherever you can access it anywhere that you want to, you want access to, right? That's why most of us now can, some people can work remotely and stuff, because you can access it from anywhere, right? Because you're using the internet. Now, resource pooling, I think we just already explained, right? All of us can get access to different resources in the cloud, right? Using the same, you can share the services. You can, if you want, you can have dedicated systems to you, right? But then you can all get access to a particular machine at the same time, using it at the same time, right? So that's the whole point of the resource pooling. And then scalability and rapid elasticity. Now, what this means is that because it's on demand, right? You can just get access to it. Or let me use this analogy. So let's say it's on demand. I go in, I create a server, and the server has 8 gig of storage, right? 8 gig. Now, maybe after using that particular server or that computer, let me be using my worst case. I want us to really be on the same page. So, using that particular computer, I realized that actually eight gig of storage is actually small for me. It's not going to help me, right? I'm getting to store more data, right? As I mentioned, I'm a startup, so I'm not starting, right? But then after 1 hour or maybe 2 hours, I realized that I actually have to store more data, right? Now, one advantage of cloud computing is that I can just go in and increase the size, I can just scale easily. As I can just go now, okay, right now I need maybe I don't 8 gig is not enough for me. Now I need 20 gig, 20 gigs of data. I can just go in, click, increase the size of my machine, and that's it. Right. So you can easily scale, right? Whereas if you're using, servers on your own, on your on-premise, right, on your in your own data center, if you want to increase the size of your machine, you have to now order, whereby buy order, get it installed, configure it and everything, right? And that might take weeks, at least a week. It has to take you at least a week, right? Depending on where you are, right? And but with the cloud, you can just get access to it within a matter of minutes. You can just do that within a matter of minutes, right? And rapid elasticity. Now, just like how you can increase it, you can also reduce it. So if I by provision maybe I created a computer in the cloud like with 8 gigs of data, I realized that 8 gigs actually is too big for me, and right that means I'm being charged more, and I want to reduce it. I can just go in and reduce the size of the machine that I've created, right? So that's how flexible cloud computing makes but makes working with tech in organizations easy for people. Like it makes it so easy. It has that ease of use, right? It makes everything so easy for everyone. Right? At this point, are there any questions? Any queries? Are we all on the same page? Let's see.
Yeah, we have one question. Is displayed on your screen? You are muted. Hello, Ebenezer, you're muted.
Oh, sorry. Can you hear me now?
Yes, I can hear you now.
But did you get at what point did I get muted? So that I don't know whether you heard.
When you asked for the questions.
Oh, okay. So can I throw more light on virtualization? Right. So um I might get a bit technical here, so let me try and use a diagram. Right. So I hope you can see my screen where I have draw.io opened.
Yes, we can.
Right. So let's take for instance, you buy a computer, right? Like this. It's big, right? And now you want to share this computer with other people, right? As I mentioned, so maybe there's me here and there's Amaka here, right? Now I want to get access to this machine, right? Resource pooling gave me access. Okay, let me get here. And then it also gave Amaka access to the machine, right? But then we are all using the same machine. So what virtualization did is what? So a virtual machine is actually just an operating system. It's just an OS, right? And with that, you have something called you. So with this machine, you have your OS stored on it, right? That particular OS. So let's see, OS, right? Now, mind you, we are all having access to this, right? So what this OS is that it has another layer that is installed in it called a hypervisor. As I said, I might get a bit, technical. Sorry for that. And I'll explain what the hypervisor does. So there's another layer on this OS called the hypervisor. And then, okay, spell it. Right. Now, this hypervisor is what allocates different resources for us. So now let's say now this is me, this is Amaka. We want to get access to this computer, right? But we want to have it, we want to have it peculiar to us, right? So this is what it's going to do. The hypervisor can divide this computer into two. Sorry, right? It divides into two, like to share the resources amongst us, right? And now, if maybe I'm more proficient with Windows, I can install another OS on this hypervisor or on this virtual machine. So what the hypervisor does is that it creates two virtual machines for me, right? So this is virtual machine one for me, this is for Amaka. Now, if I'm proficient with Windows, I can just install Windows on it. Amaka too can install, if she's more proficient with Linux, right? She can use, right? Then you have your application that you normally store your computers, right? So this is the whole point of virtual machine. So as I mentioned, as I use that analogy, so let's take that this big machine. Let me just type that here. My organization goes to buy this big computer, right? But then Amaka and I are, what, employees, and you're like, okay, now we want to share this machine amongst between Amaka and I, right? Now, what virtualization does is that it installs an OS that has a hypervisor, right? That's what it's called. That's the main component that does the whole division for us. So with a hypervisor, it can then what divide the computer into two. You can share the resources, the bare component, the hardware component, the resources of that computer. I can share it for both of us here, right? So now I'm here, I'm thinking that, oh, I'm the only one that has access to this computer. No, I just have access to some resources of this computer where I've installed my Windows machine, my Windows OS on it. Amaka too might think that, oh, she's the only one having access to this computer, but then she's actually sharing this with me, right? So going back to the analogy that as I mentioned earlier, so you have a piece of land. Let me just it is. You have a piece of land, right? You bought this big piece of land, and you built an auditorium where many people. What's this? Okay, right. You built an auditorium where many people can get access to it, right? So I'm here. Amaka to sorry. Amaka is in it, right? Now I can see Amaka right now. What virtualization would be like, okay, fine. We want Ebenezer to have his own set of resources. We want Amaka to have her own set of resources. When I say resources, that means her own kitchen, her own bathroom, her own living room, right? What we'll do is what? We'll just divide this into two, this particular auditorium into two apartments, right? Now, if Eben is here, he has his own resources. If Amaka is here, she has her own resources, right? Now, right? Amaka has her own resources. I also have my own resources, right? Now, if I'm in my house, I don't know what is going on in Amaka's house because Amaka might be in a room watching TV. I might be in my room, in the kitchen cooking, right? So it's the same building, but then we've been divided into different apartments. That's the same idea here too. You have one big computer, right? You install a virtual machine or you install this OS with the hypervisor on it, right? And the hypervisor is going to divide that computer into different, let's say, different virtual machines. That's why it's called virtual because it's actually an illusion. It's virtual, right? It's not actually real because it's just one big computer that has been divided into separate parts for you, right? So that's the whole idea of the virtual machines or virtualization. It gets deeper, but then at the surface level, I think this should be, okay for you to understand that it's just a big machine. That's why sometimes I don't know how many of us have worked with, VirtualBox, right? With VirtualBox, you can install it on your Windows machine, right? Then you can create, if I'm using Windows, I can create different kind of virtual machines on it. I can have a Windows, Ubuntu, a Linux, Kali Linux, all those kind of, different virtual machines on my computer. Now my laptop will become that main computer. Then the virtual box becomes that hypervisor level that divides it into different OSs or different, virtual machines for me. As the person asked the question, is the person okay or the person will need more clarity? Are you okay? Can I move on? Or are there any other questions? Um, Amaka, can I move on? Okay, right. If am I audible though? Can you hear me? Hello. Oh, hello, Amaka. Are you there? All right. I think I can move on. Maybe there are no other questions. Right. So those were the characteristics of cloud computing. Now I want us to look at something called the cloud service models, right? So now we mentioned that yeah, the cloud is you basically having access to another person's computer, right? Now, what the cloud service model does is that it shows you the level of access you have to that computer, right? How much of customization can you do to that particular computer, right? And whether there are three service models, right? We have the infrastructure as a service, and then we have a platform as a service called PaaS, and then software as a service. Now we're going to go into the different ones and see how they all piecing together. Um, right. Let me use an analogy to explain these things because just reading it gets somehow overwhelming if you're new to it. Right. So let's take for instance you are going to bake. You want to bake a cake, right? Now you go to a bakery that okay you want cake. You want to bake a cake. You want cake to eat, right? And then the baker says that okay, if you want to bake a cake, I'm going to give you the oven. I'm going to give you the tools. I'm going to give you the maybe the what do they call it? Maybe a knife. They're going to give you the ruler, right? They're going to give you the tools to bake it, but then you have to bring your own ingredients, and also you have to bake the cake, right? So the what the baker does that he gives you the tools, he gives you the bare tools, right, for you to bake it on your own, right? And that's the same level of that's the same idea here too in the infrastructure as a service, right? You're going to ask for a service, a compute service, and maybe AWS is like, I'm going to give you the computer, right? But I'm not going to give you, I'm going to give you the virtual machine, but I don't have an OS on it. So you have to bring your own OS. I don't have any software installed on it. You have to bring your own OS, right? So that's how it works. That's the whole point of the infrastructure as a service. If you read the definition, you see that provides virtualized computing resources over the internet. Users can rent virtual machines, storage, and networking components, right? And they have control over the operating systems and the applications. So you have to bring everything on your own. They are going to give you that virtual environment, that virtual machine, right? It's like you're going to buy a laptop with no OS installed on it. If you go and buy a computer, right? You have to choose. Okay, I'm going to install Windows on it. I'm going to install Linux or something on it, right? So that's the whole idea here. Infrastructure as a service. That's what it means, right? They're going to give you the infrastructure, the bare minimum, basically, right? They're going to give you the bare thing for you to customize it on your own, right? So that's the whole idea of the infrastructure as a service. Now, if we move on to the platform as a service, right? Now, with the infrastructure as a service, you have all the control, right? You have all the control. You have all the control. You can do anything you want. I think I made a mistake here. It's supposed to be P. Sorry for that. Right. So with the platform as a service, or they're like, okay, now come, we're going to give you the virtual machine, right? And we're also going to give you some, the OS, right? But then you have to bring your own application, right? So using that analogy again, the baking analogy, they're like, okay, fine. If you want to bake a cake, I'm going to give you the oven. I'm going to give you the knife. I'm going to give you a spoon, the ruler, right? But then you have, and they're also going to give you, they are going to give you the ingredients, right? They're going to give you the ingredients, but then you have to bake it, right? So it's like they're going to give you this, they're going to give you that, but then you have to bring your own, you have to come and bake it, right? So that's the whole platform as a service. Like they're going to give you a level of customization. You don't have access to everything, but they're going to give you a level of customization to it, right? So with that, it's like you have a platform. A clear example is, I don't know who has worked with Heroku before. So Heroku is like, you can just bring your code, right? If you're a developer, yeah, you just have to bring your code to come and host your website on it. You don't have to do any, serious configurations or customization. It's just there for you to come and use. Another clear example is in AWS, it's called Elastic Beanstalk, right? They set up the virtual machines and the OS and the networking components for you. And all you do is just what? Bring your application code and come and, host your application, right? So that's the whole point of the platform as a service. It gives you control, but it gives you only a level of control to it, right? Now, let's move on to the software as a service, right? So with the software as a service too, with this, you don't have any control over the applications. All you do is what you come, the machine has been set up for you, the 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 OS and other applications have been set up for you. All you have to do is just come and use the software. Right? You just come and use the software, right? So a clear example is your Gmail, right? With Gmail, you don't go and install anything. If you want to use Gmail, you just go in, click on it, click, send your email, you're good to go. You just come and use the service, right? So using the bakery analogy again. So there's the case where it's like you want cake, you go to the bakery, the baker has the oven, gives you the oven, right? The baker gives you the ingredients, the baker also bakes for you. All you have to do is what come and eat the cake, or come and maybe serve the cake, right? That's the whole point. So the the service models is what is giving you is it just defines how your level of access to the resources you are getting access to, right? Now this I included this diagram or this image here so that it gives us a clear um, understanding of what the service models are. So, as I mentioned, if you are doing on premises, if you're having everything on your own, that means you have to do everything. You have to set up from the basics, the virtualization and everything. You have to set everything up on your own, right? But then, if you move to the infrastructure as a service, right, as you can see here, the orange part is what you manage as a customer, and the gray or ash part is where the service provider manages, right? So here the networking components are done for you, virtualizing up to virtualization, right? You're giving a service, the storage and everything, right? But then you have to bring your own OS. If there's any middleware runtime, the data and application, you have to do all that on your own. All you get access to is the virtual machine that you have, or they give you, right? With the platform as a service, it goes a bit higher, right? It gives you the runtime, the OS, and everything. All what you have to bring is what the data in your application, right? So the application code, the kind of data you're bringing in, you have to bring it and come and use it, right? And the software, the service that okay, you don't do anything at all. You just come in and come and use the software, and you're good to go, right? So that's the cloud service models. When anytime you hear service models, if maybe you go for an interview, that's what they're talking about, right? Now let's look at are there any questions at this point? I don't know whether you can hear me or not. Right, but I think we can move along. And then the next part is what we call the deployment model. So even though you have the service models, how you the level of asset that you have access to it, right? That's also called the deployment models, how they are deployed for you, right? Now there are four main at this point in time. There are four main deployment models. You have the public cloud, private cloud, hybrid cloud, and community cloud. So the public, that's what we all mostly use, most of the time we use, like AWS, Azure, Google Cloud Platform, and GCP and everything, right? It's accessible to everyone, right? So today, I can just go in and go and create an AWS account, create a server, and I'm good to go. Someone who can just go in, right? So far as the person has access to the internet, the person can just go in and just create an account and start working with the cloud, right? So that was the public cloud. It's accessible to everyone, right? It's made available to the public. Now for the private cloud, it's like okay, I'm an organization. Like okay, I don't use the virtual machines that everybody's getting access to, right? I want it to be set up for only my organization, my own private space, right? Where no other person getting access to it, right? So if you read the definition, it says cloud resources are exclusively used exclusively by a single organization, right? It can be hosted on premise, so you can set it up on your own premise. So it's kind of close to on premise, but it's not really on premise because as I said, there's a level of virtualization to everything. So whether you're not and not everyone is getting access to it. It's set up exclusively for your organization. It can be set up in your on premises environment, or it can be even be done by a third party provider. So maybe AWS can set up a private space, right, in their own data centers just for you, right? So that's a private cloud. Then the hybrid cloud, here it says that it combines both public and private cloud. So let's say I'm an organization, I want to be using a private cloud, but I also want to be using some of the advantages of the public cloud, because the private cloud is much more expensive because everything's being set up for you, right? So that means it's going to come at a much higher cost. So maybe you want to take advantage of that and you want to use some services, right, in a private cloud, but then some services you want to use it in a private cloud, in the public cloud. So when you combine both, and it's possible you can combine both, and it gives you that kind of hybrid architecture where you're using both the public and the private, right? So that's the whole idea of the hybrid cloud. Then you have the community cloud, right? So it says that shared infrastructure is used by a specific community or a group of organizations, right? So a very clear example is the gov cloud, where government agencies have all come together. Like, okay, the government goes like, we want to use a cloud, but then we're a group of agencies. Maybe I don't know where you're joining from, but then maybe you have the health ministry, or the finance ministry, right? They all want to use the cloud, but then they have all these agencies that are also involved. So what they can do is that go to a third party provider and be like, okay, we want to have a community cloud where it's sort of a private cloud but for a group of organizations, or a group of or a community, basically, right? So these are the deployment models, how the cloud can be deployed for you to use, right? So we have the public, private, hybrid, and community cloud. Right? So as I said, if you go to an interview and ask about these things, these are ways to go about it. So please get a distinction. There's what the service models and there's what the deployment models, right? You have to know these things. These are the basics that you have to really grasp. If you don't get it, it might get confusing along the way. Now let's look at the benefits of the cloud, right? I mean, when I was talking about the characteristics, I think you can already tell that some of them are really, really beneficial, right? Now, the first point is cost efficiency. Now, as I mentioned, it's on demand, meaning it's pay as you go. So you go in, you pay for only what you use, right? Whereas if you are supposed to set up a whole server on your own, and maybe you go and buy a whole server, but then you use only maybe 5% of its capabilities, right? You still pay for the whole computer, but then you're using only 5%, right? But with this, with the cloud, you just pay for what you used, right? Now, there's also maintenance costs. Now, if you buy a server on your own, right? If it goes down, you have to service it, you have to maintain it. But with cloud, you don't even know what is going on in the background. All you do is what, just come and use it and go. So all those costs are being put on the cloud provider. You don't have to bear those costs, right? So that's why it says that it's very cost efficient. It's pay as you go. You only pay for what you use, and you just leave. And also the maintenance, you don't have any cost to that. Now, scalability, as I mentioned, if you've gone to provision a very big sized computer, right, and you see that okay, you're not using that anymore, you can just what, go in, reduce it. If also you need more capacity, you can just go in and increase it. So it makes everything flexible for you, right? If you have a server on your own on your on premise, right, you would have to, if you need more space, as I mentioned, you don't have to go and buy, order, set up the components, configure, right? By the time you get that done, I mean, whatever you needed it for would have, caused damage, right? But then because the cloud is very scalable, you have all these benefits made available to you. Now, the next point is reduce capital expenditure, right? Now, let's say I'm a startup and I need a server, right? I don't if before I want to set it up on my own, I would need to raise capital, and servers can really cost, right, thousands of dollars and stuff, right? Now, if I want to use the cloud, I don't need to plan for that. I don't need to go in and now go and sit down and be planning on how to get capital for that. I can just go into the cloud, set it up, and I'll just pay for what I use. Right. So with that, you have reduced capital expenditure. You don't have to sit down to plan and go to investors to get money or something. You can just go in and just set everything up on your own, right? So you have a reduced capital expenditure. You don't have to waste much more money on that service, where maybe you can use that, you can channel that capital into other parts of your organization, right? So the cloud has really helped a lot of startups, right? Now, reliability and availability. Now, if I have to use the same analogy, if you're supposed to set everything up on your own, right? You set up your computer or your server in one data center, and that's it. What if that data center catches fire, or what if there's a flood, right? You lose everything. Now, one thing that I've realized, having experience with AWS and Microsoft, is that if you upload or you store your data in the cloud, right, they make it redundant in the sense that they will store it in multiple locations for you, right? In AWS, it's called the availability zones. So they'll store that in multiple locations. So you have one data, and to be stored in, maybe, let me use Ghana, it will be stored in Accra, Kumasi, and maybe another place, right? So they store it across multiple locations so that in case one location goes down, there's something goes wrong with it, you still have access to your data, right? So that means it makes them really reliable, and makes your data to readily available for you, right? Then accessibility, as I mentioned earlier, you can access it so far as you have internet connection, you can have access to your resources, right? And then competitive advantage. So let's imagine now, if I want to set up, now I have to order servers, I have to, configure it, I have to order it and everything, right? And maybe we are two startups trying to do the same thing, right? By the time you set up your service, if I'm using the cloud, I'll be done in within an hour or two, right? But then to take you maybe a couple of weeks to do that, right? So if we are two startups, it gives me the competitive advantage because it gives me a faster time to market than you, right? So it speeds up the whole startup process for many organizations, right? And then final point is security, right? Now, as I mentioned, if you're setting up on your own, you have to, set up the security measures and everything, security policies and everything, right? Whereas the cloud providers, they have much more experience. So let's say physical security. If a data center, maybe you need security men to be at the data center. If it's, what do you call it? The ventilators and everything, you have to set up everything on your own. But the cloud providers have everything set up for you already. All you have to do is come and just use the cloud and just move away, right? So with that, you have improved security. Whereas if you're doing it on your own, it will take you much more time and much more, money to set everything up, right? So these are some of the benefits of the cloud, right? Are there any questions at this point? I don't know if
Yes,
Madam
yeah.
can hear me.
Hello. Can you hear me?
Yeah, are there any questions?
Yes, yeah. I'm putting it up on the screen now.
Sure.
Mhm.
Right. So middleware is kind of um okay, you've taken me to a bit of programming here. But yeah, so a middleware, let me use a programming concept, or let me go back to my screen. So a middleware is like let me move this, or let me just move somewhere here. So maybe as I said, I'm going to use programming. I don't know whether I think I've seen you guys doing some programming already, but if not, let me just use this concept. So let's say the person who asked the question is here, and then you want to access a website, right? Let me just use this for you to get the whole idea, right? The name itself explains everything, but let me just use this. You have a website here, right? You go to maybe google.com, and it's trying to send you to this particular website. What a middleware will do is that, okay, before this request goes into this particular server, it can perform certain operation on that request. This, it might be a bit advanced for some people, but then, let me do this. you just want to perform a certain um, I'm trying my best to make this as basic as possible. So okay, so now it gets to you have an application stored on this server. This is your server, the server, right? And you have maybe the application stored on it, and I want to access to it. I want to get access to it over the internet, right? Now, what a middleware can do is that before your server comes in, let me use okay, let me use this. So this can be your middleware, right? It just it's like a middleman. It does something to your request before it gets here, or even if that particular application is sending a request back to you, right? Now you've requested for something. Sorry, right, right. What the middleware is that does is that okay before maybe your request goes in, it does some manipulation on that request before it gets there, or even when the request you're getting a response to that request, it does a little manipulation before giving you that response, right? So that's the whole concept of middleware. Just like the name, it does a bit of computation on stuff or requests before they get in. Now in OS levels, like as I mentioned in the virtual machine level, it basically does the same thing, right? Because if maybe this is your hypervisor, this is your OS here, and you have an application here, right? And you have a middleware, it does the same thing. The OS controls everything that you do with your computer, right? So maybe your application is here, your OS is here, and the middleware, as I mentioned, can be here doing something to the request, maybe from the OS to the application, right? So it's like a middleman basically, just like the name goes, like it does something to it, right? Now there are different scenarios where that is used, but it's a bit advanced for the introductory class. So just take it right now as that it's like a middleman that does something to request before they get to their source or get to their destination, right? Um, the person asks the question, is the person okay? Are there other questions also? Amaka, are there any other questions?
There are no questions for now. Can go on.
Okay, all right. So I think we are getting to the end of the slides. Now, this is something that I brought in, last minute that I thought that it's very important for us to know the shared responsibility model. And this image is actually from AWS, but then, as I mentioned, with my experience with Microsoft and AWS, with Azure and AWS, I think it cuts across them. Right? It's called a shared responsibility model. So the shared responsibility model just indicates, you as a cloud customer and also the cloud provider, what are your responsibilities and also what are their responsibilities, right? And let's use a very good example with AWS. So, in as much as everything is being provided for you, right? You can get access to software, you can get access to virtual machines and everything. You also have a responsibility, right? You have a part to play in this, in the sense that, as I mentioned, well, that also depends on what the service model that you're using, right? As I mentioned earlier. So let's take the one that cuts across. So as I mentioned earlier, the cloud providers are going to give you, the virtual machines, and the virtual machines that can be in, physical location, data centers. So the hardware, the bare hardware components, you don't have access to it. It's a cloud provider that's going to have access to it. Meaning they bear all the responsibilities that surrounds that particular hardware. So if it's a data center, they have to hire the security men to guard it. They have to hire the ventilators to make sure the place is always cool, the service is always cool. Um, there's the places should be well protected, right? If there are routers being used, the routers too, they have to make sure that they're always up and running all the time. So when it comes to hardware, it's solely the responsibility of the cloud provider. Now, a bit of the software too, as I said, depending on the cloud service model, right? So if maybe you are using the SaaS, the software as a service model, software as a service model, right? All you need to do is that all you need is to just go in. So that means Google has to make sure, if you're using Gmail, that means Google has to make sure that the Gmail is always up and running. All right, you just go in and go and use it. So there, from the hardware components to the application level, it's all the responsibility of the service provider, right? Now, let's say you're using maybe infrastructure as a service where you have access to a little bit of the, you have a little bit of control or customization, right? There you have the responsibility of what installing the OS, right? Configuring the OS, bringing the data, and making sure that there are levels of access to that data. That means security, right? You have to specify who has access to those particular applications or OS or the data that you have on the virtual machines, right? So if you look here, they're saying that client side data and encryption and everything, it depends on you. Some aspects it depend on the, as I said, depend on the service models too, right? You have access, you have the responsibility of what, of the server side encryption too, security wise, right? Network traffic and encryption, protection, encryption, identity, and integrity, right? So let's say for instance in AWS there's a service called VPC. That's what it gives you. It gives you a virtualized network, right? In that, you have to set up the firewalls. That okay, I have this virtual network here. Who can get access to it? Is it available over the internet? Right? Is it just available within my network? Right. So all those responsibilities relies on you, the customer coming to use the cloud service. Right. The operating system is on you. Network firewall configuration is on you. The application security is on you, right? So I want you to picture this, that anytime you're going to use the cloud, take it upon yourself that anything concerning hardware is for the cloud provider, but anything above that is on you, right? And I think that that's why cloud engineers are there now, because you need someone with expertise to come in and come and do all these things for you, right? And that's why it's a very good career too. I like the fact that there are a lot of you trying to get access or get launch a career in this. It's a very nice career path to go in. So as a cloud engineer, let me just tell you, this is what you're most of the time going to be doing. It's only very rare, depending on the organization, that you also have responsibilities concerning hardware. But generally, as a as a cloud engineer or a cloud architect, we are going to be dealing with what, the customer's responsibility, right? Configuring all these things for the customer, right? So that's the shared responsibility model. Um, these are some of the things. I mean, with my experience in interviews, you can go in and ask him all these things, right? So just know that down. As I mentioned, I didn't want to include it, but I think it's very important that we also know that in as much as the cloud is being made available to you, you also have a responsibility to play, you have a responsibility in there, or a part to play in there, right? So I think that will bring me to the end of my presentation today. Are there any questions, any queries for me to answer? If there's anything that you didn't get right, I want me to clarify for you.
Yeah, we have
Um,
a question here. So I'll put it up on the screen.
yeah, that'd be great.
Okay, can you see it?
Yes, as a cloud practitioner, is there any advantage of choosing a particular programming language, say Python, JavaScript, C, and others, over others? So this there's this joke that they say that all engineers have a very common answer to questions. That is, it depends. The answer is it depends, and I would have to use that same answer here. It depends on where you are working, the kind of customers you're working with, right, and what they are using, right. But what I've seen that is very popular in the cloud space is Python, right? Python and JavaScript. I think Python is much more prominent in cloud, right? Because it helps in automating a lot of stuff in the cloud. Now, as I said, it's a very nice path that guys have taken, right? As you get deeper, you realize that all these things that I'm talking about, you don't have to do them on your own. You have to, it gets to a point that you have to, automate them, right? Because if you get a customer that has hundreds of accounts, you can't be going to the accounts and be setting up every time. You can just use Python to run a script for it to automate everything for you, right? So as a cloud practitioner, I would personally, advise you to going for, Python. That will help you so much, so much. Because there also it's also very well known and has a lot of libraries for you to use to choose from. Yeah, so as a cloud practitioner that you're just starting out, Python will be the best option for you. Yes. So why is AWS not the one providing security? They are providing security. So as I mentioned, it depends on the service model that you are choosing or you are using. Now, security in the sense that your network, if you set up a virtual network on them, nobody, right, outside can get access to that virtual network, that private network that you set up, right? But then if you can open that access, they can't do anything for you. Above the hardware level, right? As I said, also depending on the service model that you've chosen to use, right? And when I say service model, like there are some services in maybe the cloud providers, right? That gives you that level of customization, that level of access, right? So you don't have access to the physical. I just want you to know that you don't have access to the physical machine. So that means with the physical security, it's all on AWS, right? Now the reason why they are not the one providing that security above the hardware level, right? Is because now maybe for me, I don't want maybe anyone to have access to my network, right? I don't want anyone to have access to it. That's for me, my organization. But then what if I'm in my organization, I'm hosting a web server, right? And a web server, you have to make it accessible to all. Everyone must have access to it. So that's why you can go to Facebook because it's accessible to everyone. Right. So with that one, that kind of network is somehow open to the public, right? So now, if they go and take out the security on their own, on themselves, and maybe they shut down they shut everything down that nobody can get access to it, and maybe for your use, you want to have you want everyone to have access to it, right? It's not going to help, right? So that's why they kind of leave that part to you, right? It makes everything flexible for you, the user, the customer, right? It's not actually a downside; it's actually a plus for you. But then also, it can get dangerous for you if you keep on opening your stuff to the internet. It's going to cause issues for you and your customers. Right? So they provide security, but it depends on the service model you're using, right? Are you okay? The one who asked the question. Okay. So cloud engineering only connected to hardware and software reform like front and back end. I'm not really getting the question, but then um, so yeah, I don't really get the question, savior. But then, as I mentioned, it's like yeah, um, it's someone talking, right? Okay, so as I mentioned, right, it's just a community or a class of computers in someone's data center or someone's house, right? That they've presented to it on the internet for you to come and use. So if that's the question you're asking, that's what cloud engineering is, right? Or cloud is, right? It's not magic. It's someone's computer that you're just getting access to over the internet. It basically does that. That's cloud computing. Is it front or back end stuff? Uh, with this question, it's the question is kind of is I would say back end because you're dealing with much more servers, so server administration, right? So you setting up the servers and everything. So I'll be more inclined to back end if you like to put it that way, because as you're setting up the servers, you're configuring the servers and everything. Okay, so yeah, so back end. I would say back end if that makes it clear for you, right? So you just set up the stuff at the back for them. So servers, the backbone of all their infrastructure. You are the one setting up everything for them. Does that answer your question, Sylvia?
Yeah, that should answer the question. Thank you, Ebenezer.
Yeah.
Okay, so there are no other questions here. I think that answered all the questions for now. So thank you so much for this session. I believe I've learned a lot, and would also get the slides to share with them so they can go through as well.
Sure,
So
sure.
thank you once again for your time. I think that
Um,
wait, one more question before we go, then we can wrap
yeah,
it up.
sure.
Yeah.
How does code writing and data structuring come into computing, into cloud computing? So it's it doesn't come into cloud computing. Cloud computing actually relies on these things, right? So writing code, data structures, and everything, they are the backbone of most of the things that we see right now. Anything tech, right? So it's like cloud computing is actually just built on these things, right? So as I said, a cloud computing is basically someone's computer that gets access to it. How are you going to get access to it? It has to be presented to you over the internet. How is it being presented to you over the internet? Code, right? So right now, if I should go to AWS, right, there's a web page, and the web page is going to be coded. There's going to be a lot of programming languages behind it, right? You, even the hypervisor that I even explained earlier, and OS is just a program. So right, it's code, right? So it's this question I asked, like it's actually cloud computing that's actually being built on these things, these fundamentals of technologies or computing, right? So it's actually built on top of it. So um if maybe the question that you're asking too is that how, okay, yeah, how you are going to use these things in cloud computing. You will need it. You need coding, some coding skills. As I mentioned, you can AWS makes everything, or some cloud providers make everything easy for you, where you can just go in and you have a very nice interface and just click and just set up everything. But then as you get work where it's like you have a lot of clients who work on at a particular point in time. Let me just use a personal experience. I worked on a project where that the customer had over 100 accounts. Now, how are you going to go in and be setting up everything account by account, right? It's going to be so tedious for you. So, the best thing is to what, if you have some programming skills, especially Python, you can just automate it and just runs the script and just goes through all the accounts and just set up everything for you, right? So, coding is really important. So, all the computing stuff, the fundamentals that they actually use in cloud computing. All right. So next question is, will there be conflictions in programming languages when handling cloud infrastructure for organizations? Supposing like the cloud practitioner is using Python and the organization is using Java. Yeah, so it's yeah, you kind of get those scenarios sometimes where it's like you get a customer that maybe you are proficient in Python, but then they are using Node.js, JavaScript. So something like that, you would have to, upgrade yourself and learn it. If you can, you have to learn. If you can't, you have to bring someone on board that knows the Node.js, because you have to do what the customer wants or the client wants, right? So even with the cloud providers, right, you can be more proficient in AWS, but then you get a client that wants to use Microsoft Azure, right? So with that, it's either you have to learn it or you have to bring someone on board that has that knowledge in that. So yeah, it's one of the, let me say, downsides, but it's not really a downside. You can learn it. So yeah, there can be conflicts, as you mentioned. Right? Are there any other questions?
So there are no other questions. That's all questions we have now, Ebenezer. Thank you so much.
Sure. If you have more questions too, as I mentioned, my LinkedIn, you can just shoot me up a question and we can continue from there. Once I see it, I'll respond to you. So,
Oh,
yeah.
all right. So guys, you can follow him on LinkedIn. I'll also drop his LinkedIn handle, but you can, if you go to the Top Universe page, you'll see his LinkedIn handle being attached to this particular post. Thank you so much, Ebenezer.
Thank you very much too for your time.
All right. Thank you. Have a lovely day ahead.
All right, you too. Thank you.
Bye.
Bye.
Thank you. Bye.